friends, my name is Javir and today we are going to learn about something special in case of FEM. So far I had uploaded more than 3 or 4 videos related to FEM theories and derivations. Now it is something practically where it is applied and how we can use those theories in terms of solving the practical examples. So one of the example is given here. Here two elements. The element is given which is having 250 millimeter square area here and 400 millimeter square area, as well as 150 in length and 300 in length, and at the center point of it, after 150 mm, one force P is acting on it. P value is 300 kilonewton, and the Young's modulus of elasticity would be 200 gigapascal in it. So what is our task? To find out the nodal displacement. Whenever this kind of force is acting on this kind of element, how much nodal displacement would be there? That is our first task to be find it out. Second task is find out the stress element, stress within the element, and the support reaction. Now I request you, before starting the elimination approach, I request you to revise the equivalent stiffness matrix from the spring element. Those videos uploaded previously on the YouTube. Just subscribe on my channel, go to the playlist. Inside the CAD playlist you can find out this video. Also I had plotted in the description this kind of element, how find out from the description. Just click on the link from the description also. Okay, so what I had done, I divided this element into 3 number of equals part. It means the first part is 150 mm element. Okay, so this one is the K1 is representing this first part, 150 mm element. The K2 represent another 150 mm element, and the K3 represent another 300 mm element. So I just divided this part into 3 number of equal parts. 1, this is 2, and this one is 3. And I am knowing that P is acting at the center part of it. Here P is acting here. Okay, so P is acting at the node number 2. So now from the theory, from this video, you are able to justify that how this stiffness matrix is derived. K into Q is equal to F. K1 minus K1 minus K1 K1, K2 minus K2 minus K2 K2, K3 minus K3 minus K3 K3, Q1 Q2 Q3 Q4, F1 F2 F3 F4. What is our task? To find out Q1 Q2 Q3 Q4, and our approach is elimination approach. Okay, so in case of elimination approach, whatever will be the support are fixed. Those taken as nodal displacement of those supports are taken as 0. So Q1 value will be 0 and Q4 value will be 0 as mentioned here. Correct. So now what is the value of K1, K2, K3? So in order to find out the value of K1, it is A1 E1 divided by L1, which is also already discussed in terms of strain energy equation, where we have found out the element stiffness matrix 1/2 QT KE into Q. So where KE is AE divided by L, 1 minus 1 minus 1 1. So thus just applying this theorem here in order to find out the value of K1, A1 E1 divided by L1, where A1 is equal to 250 millimeter square. So multiplied with 10 raised to minus 6 in order to convert millimeter square into meter square. Then 200 gigapascal. E1 is converted into Pascal by multiplying it with the 10 raised to 9, and L1 is 150 millimeters, so converting it into meter. 150 multiplied by 10 raised to minus 3. In the same manner, A2 remains same 250, E2 remains same 200 gigapascal, and L2 remains same 150. It means K1 is equal to K2 and K3 is equal to A3 E3 divided by L3, where A3 is equal to 400 millimeter square, E3 is equal to 200 gigapascal converted into Pascal, and L3 is equal to 300 meter length. So K1, K2 and K3 values are known. Now in case of elimination approach, we are eliminating the rows and columns related to the fixed column related to the Q1, Q4. So I am eliminating this first row and first column here. Also the fourth row and the fourth column, because Q1 and Q4 values are 0. So eliminating those values. So what is remaining? K1 plus K2 minus K2 minus K2, K2 plus K3, Q2, Q3 is equal to F2, F3. So from this equation we are knowing the value of K2 and K3. We are knowing the value of F2. F2 is equal to nothing but the P. P is equal to 300 kilonewton. I am converting into Newton by multiplying it with the 10 raised to 3. So kilo means 10 raised to 3, giga means 10 raised to 9, millimeter square. So 1 meter is equal to 100 centimeter and 1 centimeter is equal to 10 millimeters. So 1 meter is equal to 10 raised to minus 1000 millimeter. So from that equation I am converting this 250 multiplied by 10 raised to minus 6 in order to convert it into meter square. Okay, so now Q2 and Q3 is our intention to be find out. K2 and K3 value is available, F2 value is available, F3 there is no load acting at the point number 3, at the node number 3, so it is taken as 0. So we are able to find out the value of Q2 and Q3. Just find it out at your end. This is in terms of meter. Okay, now the second thing is stress. Stress is equal to E into B into Q. You can just revise the videos which is uploaded earlier in order to find out how this equation is derived. The stress, strain and the strain energy relationship, that is the name of the video which is uploaded previously. So E into B is equal to 1 upon LE. LE means length of the element. Length of the element, first element is 150. 1 minus 1 1, Q1 and Q2, Q1 0, Q2 value will be available from this equation that you need to put it here, and that will give you the stress of the first element. In order to find out the stress of the second element, the same thing. E means the 200 gigapascal, 1 upon LE means length of the second element, which is 150 minus 1 1. Q2 Q3 here. So Q2 values from this plus band. Sigma 3 is equal to E 1 upon LE minus 1 1. Q3 Q4 Q4 0. Length of the equipment of element 3 will be 300 here minus 1 1. Q3 Q4. Okay, so just Q3 value from here, Q4 value will be 0 as per the elimination approach. Support reaction. In order to find out the support reaction, what we need to do? We need to find out the KQ minus F, means K1 into Q1 plus K2 minus K1 into Q2 plus 0 into Q3 plus 0 into Q4 is equal to R1. The support reaction would be at the support, at the fixed support. There are two reactions acting at the fixed support because of the force is pulling the element in this direction from this point. Okay, so with how much reaction will be provided? Reaction will be opposite direction of this force acting on the body, and that should be found out by using this equation. In the same manner, R4 will be 0 into Q1 plus 0 into Q2 minus K3 into Q3 plus K3 into Q4 is equal to minus F4 is equal to R4. So it is just from the equation R is equal to KQ minus F. Okay, in case of penalty approach, this is elimination approach. Now we are discussing about the penalty approach. What is written here, that the maximum value from this stiffness matrix, suppose the maximum value of this stiffness matrix would be K1 plus K2 or say K3, K2 plus K3. Suppose this value is 1, 1, 1, everywhere is 1, only here it is 6, suppose 6, and here it is 5. So maximum value will be 6. 6 will be multiplied with the 10 raised to 5 in case of this penalty approach, and that will be added at the topmost corner, left hand side topmost corner, and the right hand side lower bottom corner of the stiffness matrix. Another things remain same. What it indicates, the fixed support, actually the fixed support also having some kind of deflection, and in order to find out those deflection, this penalty approach exists inside the theory. Okay, so now the Q1 and Q4 is not equal to 0. Q1 and Q4 are the part of the element, not displacement, and F1 is equal to 0, F4 is equal to 0, and F3 is equal to 0 as there is no load acting on it. Okay, so and the other things are remain same as we have mentioned in case of elimination approach. Only the thing is different is C, part C here, and part C will play a vital role in order to find out the deflection of the support reaction, fixed support. So the penalty approach says that the fit support having some kind of deflection, and in order to find out those deflection, this theory comes into picture. So by putting those equations, K1, K2 and K3 values are available, Q1, Q2, Q3, Q4, 4 equations and 4 unknowns are there. So it is very easy for the mathematics persons to find out the value of Q1, Q2, Q3, Q4. Then further sigma 1, sigma 2 and sigma 3 and reaction at R1 and R4. I hope you like this video. Some basic concept will be revised from this video in your mind. If you have already read this video, have some knowledge about the penalty approach and the elimination approach. This video is very useful for the master degree students, those who are doing in the machine design, and very useful for the students in the 6th semester of the GTU. Please recommend those students to view this video in order to have an idea or have a glimpse of the penalty approach and the elimination approach in the academics. Thank you very much. Please subscribe so that I can motivate to upload more and more number of such kind of videos. Thank you very much once again.